Great to have you here today. So kudos to those who got up early in Orlando, Florida to come to the first session on the first day at 8 a.m. So pat yourselves on the back. You deserve to get off early today. Maybe head off at noon or so. Got our learning objectives. Those might come in handy sometime. We're going to learn about building an envelope today in a nutshell. So who is NAESCO? I'm representing the National Association of Energy Service Companies. We're a nonprofit trade association. We've been around since 1983. We've got 172 organizations, at least when I put this slide together, because we continue to seem to be growing quite a bit. We're home of the only energy service company accreditation, and that's important because accreditation helps us to drive an industry to a higher level of performance. We've got 22 accredited ESCOs, 14 accredited energy service providers, which is a little step above an ESCO, 4 accredited energy efficiency contractors. And this is a picture of our ESCO membership. People up here presenting with me today are both members of NAESCO, but they're not on this screen because they are affiliates. They provide services and goods to the ESCOs to help them complete their projects. And what's interesting about our industry that I'd like to show this about is that it's got both small companies and large companies. Probably one of the smallest on here is up in the upper right-hand corner, ESP, probably about 10 people or so. And then one of the larger companies you get down here, like Engie, Siemens, Schneider, Trane, AECOM, they compete directly against one another, and you never know which one's going to be successful because they both have an equal opportunity to win that work. It's an industry that is defined by a relationship that's developed and how well the client feels that that energy service company will serve their needs, not necessarily by the size and clout that they bring to the table because of their name. What we do advocacy, that includes lobbying. I read a story this week that lobbyists are considered the most untrusted people in the world, so now I've established myself as the most untrusted person you could possibly have. We do the accreditation program. We do workshops and conferences. We've got a conference coming up in 1 month in Las Vegas, our annual conference. We do CEU accredited webinars. We look at RFP notifications. But why we have to do so much advocacy is that our industry is governed by a set of laws that is unique in every state and the federal government. And those laws are constantly being challenged. They're challenged by the American Institute of Architects because architects don't like the fact that we get into school districts and do work when a lot of times an architect thinks they own a school district. A lot of times mechanical contractors may challenge us, unions may challenge us. A lot of times it's a misunderstanding of how our industry works and how we might be able to coordinate with those groups. But it is different, and one of the reasons we continually have to do training and education is that many times our contracts are 20 years long, and so a person at a facility may only do one of these in their entire career. And so every time you do one, it's like a new learning experience. What do? We save energy by renovating the building, and we use those energy savings to pay for the renovation. We also include operational savings, like savings that you might have on contractors to do work or savings on parts and pieces. So I'm going to cover just a little bit about building an envelope, but I'm going to have the experts come in and give more detail about window film and overall building envelope because I only know just this much and they know this much. But the reason you look at building an envelope is because 72% of commercial buildings weren't built with energy savings in mind. And what's always interesting is I used to work for the federal government, and it's fascinating to see that they constantly are looking at new building standards. And you hear about ASHRAE standards and so forth, but a lot of times those standards just apply to new buildings, but yet the buildings we deal with the most and are using the most energy are existing buildings. And so it's important that we look at existing buildings when we do these things, which are often challenging to fix. Because you never know what's going to happen when you open that panel or you take off that unit ventilator off the wall or you open that air handler to see what's going on about what might have happened in the past. May not have been a contractor that installed it, but it could have been a facility manager had to modify it to get it working because something broke and there wasn't somebody to fix it, and then that modification became permanent. The most famous one I always liked was blocked outside air intakes. That was a common one we used to run into, and it was always challenging to explain to the client where there was an opportunity for a lot of energy savings, but if we bring this up to code, you're going to use more energy because we're now going to bring the outside air in. So you never know what you're going to encounter. Renovating existing buildings is a big challenge sometimes and can be far more exciting than just doing new construction. Weakest part of a building envelope, anywhere air can leak. We're going to hear more from that from Brian in just a little bit. Weatherization. We'll hear about that as well, but one I want to talk about that Brian won't talk about, he'll talk about roofs and so forth, but It's duct sealing. We've got one of our members that does duct sealing, which is an innovative concept where you put a mist inside the duct, and the mist has been engineered such that when it detects a pressure difference, it solidifies. And so as it flows through the ductwork, if there's a hole in the ductwork and leaks out, it senses that pressure differential. It begins to form a scab, like just how your body heals, the duct heals. It begins to seal that up so that you no longer have that air leakage. And you say, well, what difference does it make? Because the air is still in the building. It's just leaked into the common space. Well, often we don't heat and cool the common spaces. So the air above the ceiling, for example, this drop ceiling, that is probably unconditioned space. And as the duct leaks, that becomes basically wasted energy that doesn't provide the comfort. Because the whole reason we're cooling this building is because of us. And they want to provide that to us. It also, of course, provides some benefit to the building as far as keeping the materials from decaying or mold buildup, because I'm sure that happens here in Florida with the humidity. When you look at how to choose a partner, energy service companies are a great choice to choose because they come in and do a turnkey project. When you work with an energy service company, it's a relationship-based selection, and it's a relationship-based performance. And what that means is that when you pick that company, you pick them based on their prior work references and their prior performance. And so that puts an emphasis on that ESCO to ensure that the work they do for you is high quality, because their next client after you is the one that's going to be calling you, asking you how well they did. And so it becomes very important that the ESCO manages not only how they have that relationship with the client, but also with the subcontractors. So people like Harry and Brian that work for the energy service company, to make sure that they provide the proper work and stay behind the work. One of the challenges we always get in the ESCO industry is people always say the ESCOs install the old tried and true safe technologies, and they're afraid of new innovations. But the reality is that they're not afraid of new innovations, but they've learned that sometimes new innovations are not the best thing to install when you have a 20-year commitment to stay with the client. I know I used to work for an ESCO, and we installed some special laundry ozone treatment system in a laundry system years ago. And contractor seemed great, but it turns out the contractor was here today and gone tomorrow. And when that thing broke down 2 years after we did the contractor was nowhere to be found. And so we had to go to specialty parts manufacturers to fabricate new parts for this thing we put in. And we had to maintain that thing for a decade. What a mess that was. And so we learned that we really want to have solid contractors to help us out, and solid suppliers and solid equipment. So your ESCO has to do that vetting, and they have to make sure that, because if something goes wrong, they're on the hook to make sure it works right, because they need your reference for the next project. I'm going to cover just a little bit on how to finance, about how an ESCO works. The way an energy service company works is you've got a total operation cost before, that's the top blue bar. They install updates to new equipment. There's some operational and energy savings afterwards, and there's some cost savings. That red cost savings becomes the cash flow stream to fund the payment back to the financing institution for the retrofits. Depending on what market you represent, if you're in the public sector market in non-federal, you probably finance it yourself because your access to capital is lower priced. The federal government laws are interesting, and they require that the energy service company provides the financing, which they just go get from someone else as well. So whoever the lender is, we did work for a college one time, a university, and they used their endowment fund for the financing. I've done work for counties and cities, and they often will have a line of credit with a bank. School districts often use bond issues. Sometimes cities use bond issues to pay for the project. How you work with an ESCO, the process that starts out is you just start to talk with them, and they'll want to do what's called a preliminary energy estimate, or something they call similar to that. And they're going to look at a building and do an initial analysis of what they think the opportunities are in that building. They're going to present that to you and give you kind of a picture of what the scope is going to be. And they do that for their own protection as well as yours. They don't want to go invest a lot of time with a full audit if there really isn't an opportunity. So they're looking for, what is the opportunity for the facility? Where do we think we can make something work here, and will it have a payback that makes any sense? If that works out, they do a comprehensive energy audit. Sometimes they're called IGA, for investment grade audit. And what's different about an investment grade audit is, than an audit you might go hire from an engineering firm, is the savings in an investment grade audit or a comprehensive energy audit are fixed savings. They're guaranteeable savings. The ESCO will stand behind those. And the cost to install are exactly what you'll pay for the cost to install. Generally, the ESCO is going to work for a no change order policy. If their scope changes because you've changed the scope or you've added scope to the work, that obviously is a change order. But as far as what the ESCO proposes, if they come into unexpected conditions, they have to absorb that cost because that's part of the way the ESCO process works, because the savings has to cover the installation cost. If new costs arise, there has to be new savings arise, which often doesn't happen. Post-installation support, the ESCO maintains relationship and working with the project to the extent that you want them to. They can measure and verify every year for as long as you want the contract to go. They can measure and verify for a short period of time. They can stay with you with an extended warranty. They can provide services where they operate and maintain, and even repair and replace the equipment. It depends on what level you want them to provide. They can do that in the ESCO project. And with that, I'm going to turn it over to Brian, who is going to tell us about building envelope.
Hi, everyone. Again, my name is Brian Scholl. I've been a project developer, auditor with Envelcore for 3 years, been kind of in the industry for 10 years. So I've been through thousands of buildings, probably millions of square feet, doing building envelope audits for the last coming up on 10 years. So when I first kind of heard about this conference, new building envelope technologies was really exciting to talk about, but what we do all day, every day, maybe isn't new. It's probably new in the grand schemes of construction, so there's a lot of building envelope deficiencies out there that exist in our current building stock that we are focusing on all day, every day in these energy savings performance contracts. So that's what I really wanted to focus on today is those existing building envelope deficiencies. So why should we implement building envelope upgrades? This is a slide all about technology stacking. So what we see a lot is researchers estimate that HVAC equipment costs could drop by up to 70% by tightening a leaky envelope. So when you implement an HVAC upgrade project and a building envelope project at the same time, you can often downsize your HVAC equipment. So it's a big reason to actually go out there and implement your building envelope projects. So whether it's a comprehensive building envelope project where you're looking at air leakage and insulation window upgrades, or if you're just looking at an air leakage project, which brings me into the next slide. So air infiltration and exfiltration is really what we do a lot of in our building envelope projects these days. This slide comes from a table from 2005 that really kind of kicked off the air leakage, air infiltration, exfiltration industry. So this is an ideal air infiltration, exfiltration project where you kind of go into a building and do a full gut renovation to find every single little air gap in a building. So some pretty huge gas savings and electrical savings, cooling savings opportunities out there from doing strictly an air leakage savings project. In the real world, there's day-to-day operations going on in our buildings, right? There's schools with classes going on, there's offices with people in them, so you can't go on and really disturb those processes. So the real world retrofit savings that we see is lower, but still really, there's still a really good opportunity out there. So you're not gonna see 57% gas savings in St. Louis in a real world retrofit savings application. We're probably gonna see 10% savings or 20% savings in a really, really comprehensive air leakage project. So unfortunately not 57%, but there's still some really, really meaningful savings out there to go after. So where are our buildings losing energy? So this graph is showing us where different building components, how different building components are contributing to air leakage in a building. Blue here is roof wall intersections, which I think we all kind of know what a roof wall intersection might be. It tends to be an area in a building, as you can see, that really dominates where air leakage is occurring in our buildings. So for a number of years, we got this intersection wrong, really through some flashing on the top of a roof wall intersection on the parapet of a wall, and that was about it. You end up deterring the bulk water, all the rain from getting in the building, but that intersection was never properly sealed, so you end up with air leakage through that roof wall intersection. We see it all day, every day. Other intersections on here, or other building envelope weaknesses on here, red being exterior doors, so it's gonna be your weather stripping, really, to go after. Green, mechanical penetrations, which Tim touched on a little bit. Anytime there's any kind of electrical contractor, plumbing, or HVAC contractor that drills a hole in a wall, not often are they sealing up after themselves, right? So we have to go in and treat those holes in the building. Windows, this is strictly air infiltration, exfiltration at windows on this graph. So it's not the U value and solar heat gain coefficient upgrades that we can see on windows. This is strictly air leakage at windows. So it's going to be caulking around a window, weather stripping windows, that kind of thing. Soffits, yellow. So soffits are going to be kind of overhangs of a building. So kind of use interchangeably, soffits and overhangs, where an overhang of a building might have a vented soffit that kind of goes directly into your building. So you end up with a lot of air leakage that kind of communicates outside air into the building, where we improperly vented a building to communicate. So I have a few slides on that one too. And then other being attics and basements and foundations and air leakage through those kinds of building intersections. So those tend to be a lot of our stick-built, kind of like our homes. We're going to see a lot of air leakage in the other category rather than the roof wall intersections that we see in a lot of our commercial buildings with flat roofs and that kind of construction. So roof wall intersections. We see roof wall all day, every day. We as building envelope auditors and developers, we walk around with ladders in every building that we go to try and get into drop ceilings and investigate what that roof wall intersection is going to look like. This picture on the top left is a building intersection in Massachusetts, and an infrared image that kind of corresponds to that image. So this is middle of the winter, 27.5 degree air that is visible from the inside of a building that is kind of forcing itself on the building. This one in particular, actually, the custodians said that in blizzards, there's so much air leakage at this intersection that there's snow that finds its way into the building and onto the drop ceiling tiles. So it's just a pretty extreme case for sure, but it happens, right? So bottom left, another example, roof wall intersection, clear daylight, so it's just a lot of air leakage going on here. And then the bottom right would be a more modern roof wall intersection construction style. So 2009, 2012, 2015, there started to be amendments to energy codes where builders were required to start thinking about air leakage at these intersections. 2009, maybe there's some fiberglass stuffed into that roof wall intersection. Unfortunately, fiberglass is not an air barrier. It's more of a air filter. It's an air permeable material, right? So that fiberglass, although a good attempt, was not really doing its job. It acts as more of an air filter, so there's still a lot of air leakage going on at this intersection. One way to seal it up, two-part spray foam. So pictured on the right is these roof wall intersections that are sealed to stop air leakage. A little more on roof wall intersections. So sometimes as a building envelope auditor, this is just, we look for spider webs. Spider webs, it's not a tried and true way to determine there is air leakage at this intersection, but spiders tend to build their webs and keep their webs in areas where there's insects going inside to outside. So sometimes we look for spider webs to try and determine if there could be some more air leakage or an air sealing opportunity. And then the bottom left again is another picture of one of these roof wall intersections that was mistreated. Really, really dirty fiberglass. Started out really clean and pink, right? And then over time, there's just been massive amounts of airflow through this roof wall intersection, accumulating dust and debris over time, degrading the R value of the insulation, and really creates an inefficient building. So rather than two-part foam, on the right here, we have air sealing with one-part foam. This tends to be a little bit better of a method for sealing a building when it's occupied. Two-part foam's awesome. There's some off-gassing concerns and smell concerns if you're working in a building with classrooms going on and building occupants. So sometimes the one-part foam tends to be preferred. You're sealing the same intersection the same way, you see the same savings, but a little more friendly for an occupied building here. Moving on to soffits and overhangs. So sometimes confused with roof wall intersections, it's kind of the same thing, kind of the same treatment methods, but soffit and overhangs can contribute to humidity concerns, especially in hot and humid climates. You end up with sometimes some confused thermal envelopes and building envelopes that have soffits and ridge vent construction like this building here in South Carolina that connect directly into the attic space. So this was an attic in South Carolina, where they just underwent a major HVAC system upgrade. So they spent a lot of money on a top-end HVAC system. Unfortunately, they put that HVAC system in an attic that had soffit venting and ridge venting, so the attic was acting more as an unconditioned attic in a South Carolina summer, which really exposed that system to some pretty extreme high temperatures. So the solution here was to close up that soffit venting and the ridge venting and bring the attic into more of a conditioned, make that attic more conditioned, really, to help out that building and that HVAC system to perform as expected. Door and window air leakage, so not really a new concept. We all know about door weather stripping and caulking, and we do a lot of it in our ESPC projects. It's just really hard as a facility manager sometimes to go through and count every single door in your facility and find the proper weather stripping to go install and find the time for folks to go install it. So every day we're going out and we're counting doors, identifying doors on buildings, and it really adds up. So a typical 7-foot by 3-foot door is going to have 20 feet of air leakage opportunity around it. So 20 feet times 1,000 doors in a school district, for example, and you're looking at 20,000 feet of air leakage or air sealing opportunity from weather stripping. So really adds up over time. And then bottom left, window caulking. So this is unfortunately another example of fiberglass being used in a situation where we want to see an air barrier material. So this is a window in New Jersey. Snap trim was installed over fiberglass in a window cavity, where many of us, if we're installing a window in our house, we're going to use a spray foam in our window cavity. This commercial window installer unfortunately used fiberglass, so you end up with air leakage through that intersection. Quick and easy way to fix this is just to caulk that snap trim back into place and allow the fiberglass to kind of do its job as an insulator, and allow the caulk and the snap trim to do its job as the air barrier around the window. And then bottom right, glazing gasket repair is another one that we see all the time. Those rubber gaskets that hold the window panes in place, sometimes they're cut short, sometimes they shrink over time. There ends up with being gaps around these glazing failures all the time. So an exterior glazing gasket and interior glazing gasket that are not cut to size lead to a direct pathway for air to leak in and out of the building. So not to mention not getting into water leakage at all today, but an exterior glazing gasket that has failed is going to lead to water leakage as well. So something that we definitely want to avoid. Building insulation, really just staying on the topic of air leakage. Insulation is really great. A lot of it is fibrous, so you're going to see a lot of degradation of R values in insulation if there's air leakage in the building. So it's really important to do that air sealing effort before you do any kind of insulation. Sometimes you can do your air sealing and your insulation at the same time through a spray foam project. So pictured on the right, spray foam at the underside of a roof. Perfect application where there's HVAC equipment in the attic, bringing that HVAC equipment back into the thermal envelope of the building so that it can perform as expected and not have to battle the extreme temperatures that we sometimes see in our attics in a vented attic. So going to the roof, also important if you're in a northern climate. If you have any kind of pipes or anything that could freeze in your attic, then you're going to want to bring your thermal envelope to the underside of the roof instead of trying to hope that a little bit of heat escapes from your building to keep those pipes from freezing. Window upgrades. Window replacement's really costly, right? We don't really see it take place a lot in our projects. It ends up being more of a capital improvement that can't be supported by the savings that our projects are generated, but we have been starting to see supplemental window system projects find their way into our projects. So another name, supplemental glazing systems or window inserts would be another term for this. They make them now to be single pane and double pane, so you can actually get a window insert that is an insulated glass unit and has a super insulated frame in it as well. So when you're looking for U-value or insulation upgrades on a window, this is going to be a really great option. These supplemental windows can also be treated with a window film so that they can have like similar solar heat gain coefficient upgrades to what a window film project alone is going to be. obviously much more expensive. So if you're looking for strictly a solar heat gain coefficient upgrade, then you're probably looking towards the window film side of the business. If you need a U-value upgrade, then a supplemental window system rather than a window replacement project could be a great path. And then on the left here, a project case study from Houston VA regional office. So this was a project that we got involved in where the customer was having really extreme condensation issues. So every morning they would kick on their air conditioner and they had single pane glass in their building that was just conducting that cool energy to the outside, right? So that warm, humid climate of Houston was causing a lot of issues. Building occupants said that they could not see outside of the windows in some of the mornings that they were kicking on this air conditioning. So they did not have a budget for a window replacement project. They went with a supplemental window route, and we put in these windows. Pictured on the right is the installed version. So it's a color match frame, insulated glass, and we were able to raise the dew point of the exterior part of the building. We were able to raise the temperature above the dew point on the exterior part of the building, so there was no more condensation. So it was a really successful project from a maintenance and aesthetic standpoint, as well as a lot of energy savings from installing one of these supplemental windows. And then nothing against window replacement, but don't replace that window quite yet. So we also see some cost savings with window restoration projects. So this is going to come into play on operable windows. So casement windows and awning windows and hopper windows have a lot of hinges that fail over time, right? Any moving part, usually it's going to fail at some point. So there's a lot of companies out there that do window restoration, so they can replace those hinges, replace the weather stripping, replace the locking hardware, and bring a window that maybe was really hard to open to like new functionality. Same thing with single hung and double hung windows. The balances that kind of hide in the jambs of those windows fail over time, and there's a lot of companies that can go in and replace those balances and bring a window to like new condition. Whether it's really hard to open initially, or you can open it fine, but then it slams shut, right? So those balances will be really helpful. And then when you can replace all the operable parts of a window, oftentimes it'll engage the weather stripping better, and you can see some savings from doing that from an air leakage standpoint as well. So when you can combine a window restoration project with a glazing upgrade, like putting window film on your windows or replacing the glass itself, if you're actually getting that foggy glass in your window, you can bring a window to like new performance for a fraction of the cost of what a window replacement project might be. So that's all I had. Just wanted to get through that quick. Thank you.
Good morning. I brought some extra coffee for you guys to wake you up. But look, my name is Harry Rahman, and I work for Expel, and we make window films. So, obviously Tim started off with a broad picture of performance contracting and what that entails. Very thankful to have performance contracting. If you guys haven't considered it for your buildings, I honestly don't know how some of these companies like Envacor are able to guarantee these savings. That's a lot to take on. There's so many variables out there, and some of the other ESCOs. So it's if you haven't considered it, something very, very important. And then obviously, thanks to Brian for sharing the holistic approach of the building envelope. I'm going to be going a little bit deeper into what I feel is one of the weakest parts of the building envelope, right? For many reasons. I want you to think about this as a room and some windows. If you're breaking into, don't get any ideas, right? So if you're breaking into this place, you're not going to go through the wall because you want to show you're stronger. You're finding the weakest point of entry, which is the window, right? Same thing with energy. That energy is not looking to come through the wall. If the weakest link is the window, it's going to find the window to go through, right? So the weakest link, part of the weakest link for heat gain and heat loss is the window. So in a factory that doesn't have windows, window film doesn't make a difference. And we'll talk about some of the factors that determine payback as well with window film. But in most instances, where you have windows, it's going to find, right? So think about heat in the summer. It's trying to find the coolest point, which is inside your building. And in the winter, It's trying to find the coolest point again. So any heater that you're using, it's trying to flow outside. Now, some of you may look at your buildings and say, all right, I've got double paned windows, right? If you've got double pane windows that were installed in the last 8 to 10 years, if it's a newer facility, you're probably in good shape. You probably don't have a lot of leakage that Brian mentioned, and your window performance, because of the energy codes in the last 8 to 10 years, is probably your window performance is pretty good. Now, if you have a 15-year, 20-year, 25-year-old facility and you have double pane windows, ordinarily you would think I have double pane windows, but in most of those, the seals are probably broken, right? Or significant number of those seals are broken. What that means is that double pane window has an insulation value, right? It has an R value or a U value to keep heat from escaping as well. That has gone down significantly. So we have today, when we look at a building, one of the first things we do is we look at the existing windows. And we do thermal imaging. We also have several tests where you can go to an existing building and test the window to see if the seals are broken. You can also test the performance of those windows to see where they're performing versus where they were performing the day they were installed, right? So one of the biggest issues with energy modeling is that if you make an assumption, right? So let's just make an assumption that, what's your name, sir? Joe. Joe's building is 20 years old, and we're doing an energy model on that building to see if film can make a difference on Joe's building or not. We make the assumption that we ask Joe, okay, what type of window do you have? And he's like, well, I have a clear double pane window, and here are the specifications on it. So if we take that model and that performance and use it in our energy model to see what kind of savings we're going to get, it won't be accurate, because that's what I called, and I think some of you may be too young to remember this, but who remembers the terminology GIGO? G-I-G-O. Anybody? You guys are younger than me. All right, okay, I see one person. All right, so it's garbage in, garbage out, right? So that's, in an energy model, that's what it is. If you put in garbage, you're going to get out garbage. So one of the first things to do is to benchmark that window, to go test that window and make sure that what is its current performance, are the seals intact, and what's its R value, U value, and so forth, which, right, there are technologies today that will allow. So I wrote a little article, about a year ago, and that's like, basically I called it addressing the elephant in the building envelope, right? The elephant is the window. Why is it the window? Because nobody wants to talk about window replacement due to the cost, the downtime, and several other factors, right? So we're talking about a lot of things around the window. We've got these beautiful windows, and we're talking about, okay, we need to put solar panels on this building, we need to do this, we need to do that. And the reality is, doing solar panels or any sort of other generation type or capturing of energy before making your building more efficient is the equivalent of turning your AC higher in your car when the windows are down. The first thing you have to do is seal the envelope of the building before you can do any of those other factors, right? So anyway, I'm just going to keep a track of time because I know Tim will got it. So okay, what do I want you to leave with? Effects of a weak building envelope on your facilities and solutions available, progression of technology in building envelope solutions, and how to assess if your facilities are a good film for improvements and incentives, right? So what are the effects of a weak building envelope? Number one, the energy bills, obviously, right? We know that buildings represent the largest sector of the U.S. economy. That's from I believe it's part of the NFRC, the National Fenestration. We've got comfort, hot spots by infrared heat. If you're in a warmer climate, you see a lot more of this, but even in cooler climates, we see this. Or leaky windows, HVAC load at certain times of the year, safety from broken glass or vulnerable areas with clear glass. Security, vulnerability of first floor windows from break-ins. We're seeing a lot of this in schools. They're concerned about the ease of breaking in. Look, anybody that says window film can stop bullets, what I recommend is you get them to sign a disclaimer, put them on the other side of the window with their product on it, take a couple of shots, right? We don't need that kind of, I also happen to sit on the board of the International Window Film Association, which is the association for window film manufacturers, right? So it can't. What we talk about is delayed entry. Can it buy you time? You better believe it can buy you time, right? We just did a video recently, an active shooter video where we took and shot 6 bullets through a window, right? And what happened was the bullets went through, okay? But the glass stayed intact. And then, so we shot 6 bullets through this window. Then we had a guy with a baseball bat, and it still took him close to 3 minutes even after that to get in. Now, thankfully, hopefully this becomes less of an issue for us to talk about, because in terms of bullets and so forth. But anyway, that's the security. Privacy from the outside or even interior places, right? You have conference rooms where you're looking for privacy. We'll talk about that. Facade, an outdated look and performance of windows. If you have a property where you look at it, you're seeing a couple of things. You're seeing half these blinds are down, right? And you're looking at that building. It's a beautiful building, but you can't control all these blinds, right? And it's making that building look a little bit more of a checkered flag type look, right? Or if you have older glass that has degraded, I'm going to show you what that will look like. We make products that you can install from the outside that can also give you not just the efficiency, but an upgraded facade look. Sustainability goals, some of you guys have sustainability goals in New York and some of the other states. You have local laws like LL 97 where you're trying to comply with certain regulations, so that can help. And then graffiti and crime and so forth. So just a quick progression of technology, right? I want you to tell me the first words that come to your mouth. Listen, I'm a married man with 2 teenagers. There's nothing you're going to say that's going to offend me, right? So positive or negative, doesn't matter. First thing that comes to your mind when you hear the words window tint. Joe?
The discoloration of car windows.
Love it. Yes, sir.
Bubbles.
Bubbles, yes. Anybody else? Sir? Positive or negative?
Just difficult.
Difficult.
Like when you think about car windows, it's like I can't even tell which way you're looking before you make the turn. So,
Yeah, so dark.
yeah.
Dark, right?
Connection points between one sheet and the other sheet.
Got it. So kind of like seaming it. Sure. All great points. So all of you are right? So window tint does exactly those things. The other problems that you incur is window tint is an absorber. It doesn't really reflect heat. It absorbs heat. So what happens with an absorptive technology is you've got this beautiful window here, this huge piece, and it's in a frame. Guess what happens when you put conventional window film on it or automotive window film on it? It absorbs that heat and tries to expand. When it tries to expand, it has nowhere to go because it's in a frame, and you see cracks, thermal stress. Now, describing today's technologies of window tint as today's latest technologies as window tint would be like describing a 1968 black and white television as a high definition entertainment center. Technology's come a long way. So I'll tell you where it's gone. It used to be exactly that, bubbles. It used to be dark. It used to be shiny. Then some innovator came up with the technology of let's separate heat and light. So when the sun's rays come in, they come in through infrared and light. So let's separate those two. So let's let the light through and let's cut the infrared heat. So now we can have a product that you can't even tell is on the window that will reject a certain amount of heat. Then somebody said, well, why are we just trying to keep the heat out? To Brian's point earlier, which is a solar heat gain, how can we keep the heat in? So then somebody came up with a new technology, right, that is able to keep the heat where it belongs. In the summer, outside, and what it does is it takes the summer heat and reflects it back out. And in the winter, the heater's heat is actually a different type of heat. It's called long wave infrared, whereas the sun's heat is short wave. So it's blocking that heat from escaping. So now it's able to do what we describe as all-season technologies, and we'll talk about that. So technology's come a long way, and instead of absorbing, it's reflecting. But it's not reflecting the visible light. It's not reflecting the shiny stuff. It's reflecting the infrared, which is invisible to your naked eye, right? So this is kind of how it works, right? It keeps the heat, just like you've heard of low-E windows, right? So all-season films act like low-E windows. You can take an existing window and apply a thin film to it that you can't even tell is on the window that will take single-pane glass. Now, anybody that would like to talk about specifics and performance would love to talk details about this. We can take single-pane glass and get you close to the R value or the U value of double-pane glass with a thin film on it. Brian, the U value of a single-pane window is about 1.0, give or take. We can take the U value of a double-pane window that was installed in 2005 or 7 or 10 or something like that is about 0.5. Right? So U value talks about the wintertime insulation. We can take a single pane of glass, 1/8 inch or 1/4 inch, doesn't matter, with a thin film, down from a U value of 1.0 to 0.6. Now I want you to think about what a double pane window was, 0.55 to 0.5. We can take a single pane down to 0.6, right? And without any downtime, without any additional factors. Okay, so what are some of the solutions for a weak building envelope, right? Window enhancement. We talk about, look, if you have the budget to replace your windows and you came to me and you had a 25-year-old window and said, Harry, what should we do? We have the budget for, I would say replace your windows. Right? We don't compete with window replacement because the window replacement is the right thing to do if you have the money, if you have the budget. And if you're okay with the 25, 30, 40-year payback, great, all good. If you don't have that and you're looking for payback, then we talk about window enhancement, right? Replacement has low payback, associated downtime, huge capital. Comfort. You could stand in front of 2 windows, and if you guys want any of your facilities, some samples installed, you could stand in front of 2 windows, one with a product on it and one without, and you can feel the difference. Forget about the thermostat, right? So you guys talk about, we talk about controls. I want you to think about something. Controls are reactive. If there's a control, if there's a thermostat right over there, it's triggered after the heat comes in through these windows, travels to those thermostats and says, hey, thermostat, it's getting hot in here. Sir, what's your name? Bill. Well, Bill's already hot by the time that heat's coming through. Bill's hot. The thermostat says, all right, click it on. Okay? It's a reactive control. We are a proactive effort. If you can cut, that's where your savings come from. If you can cut that heat from coming in, that reacts less, right? The other thing is that if you stood in front, there's a comfort factor, right? There's a comfort factor. You stand in front of a window, you take a BTU meter, you put a digital thermometer between these 2 windows, you put a data logger, a Hobo data logger that's made by Onset, and you can see, you can measure all of those, right? Safety from broken glass, we'll show you a little bit about that. Privacy. Okay, so just showing you a few pictures right here, right? That window has film on it. That window has film on it, and that window has film on it. Right? You can't, if you don't want to tell it's on there, you can. Now, there's some types of properties where you're looking for a little bit of glare reduction as well, right? This is an anti-graffiti film, right? Not common in all areas, but in your neck of the woods in New York, sir, lots of graffiti film that we install out there. It's a sacrificial layer that goes on the outside, right? When Chase Bank had a problem, it's not an issue of money. The issue is that to replace a window takes a lot more time by the time you call a contractor. This is a sacrificial layer that you can put on the outside. That's a BTU meter, right? You can buy them online for about $200. And what it does is it measures British thermal units. You can take it in front of a window, put them in front of, and you'll see the reduction. That's what happens when glass breaks with security film right here. What you see is the glass will crack. It's not that it's not going to, right? But it's going to hold it in place. So what happens is, in the Oklahoma City bombing, there were more injuries caused from flying glass than the bomb itself, right? So that's the issue, is it'll hold it. Now, I want you to look at these two buildings. That's the same building. One of the tenants went in and installed what I called aluminum foil, or I was in London a couple of months ago, and it's aluminium, right? So, but here, we say aluminum. So we installed some aluminum foil film, right? One of the tenants was like, hey, I'm done with this. Now you notice all these blinds that are up and down? This building said, look, you can't do that, right? We want something that has a dark look, but it doesn't look reflective, like chrome wheels, right? So that's that same building that was installed. I don't know if you guys can see this, but can anybody see this window right here? Can you see something reflective? Like there's this first one. Anybody? No? Looks a little shiny. I should have enlarged it a little bit. But anyway, again, lots of different technologies. You don't have to have reflection in order to. Now, this is a cool building that was done where we were talking about the external facade, if you want to change it. So this was the original building. You see some scratched up glass right here. And it got, they were trying to sell it. So they said, hey, we want to upgrade the look, and we also want to increase its efficiency. So we ended up installing that. They said, we want something shiny, something that you can tell is different. Well, it got bought 2 years later, and new management came in and we said, we don't like the chrome wheel look, right? So we actually took that off and installed a more neutral technology from the outside. They achieved the performance there. It wasn't performance. They wanted to change the look. So you can change the look of buildings as well as you think. Different types of properties, whether it's office or commercial space. In retail spaces, we see a lot of, one of the things we see is people want visibility because they want to show their stores, and so different kind of chains. Apple is a prime example. Anybody venture to guess? You've been to an Apple store where you got those big pieces of glass. Anybody guess what one of those panes costs? Comes from Germany. Take a guess. One of the larger panes could be about $75,000 to $80,000. Right? It's a quad pane unit, 4 panes. Right? Because it's laminated. It's laminated on the outside, air gap, and laminated. So there are actually 4 panes of glass in there. So when we were doing some of that, extremely, extremely large spaces. So lots of different types. Historic properties. Window tint in the past could not be used on historic properties because it was dark and it changed the look, right? Thanks to our friends at Envacor, we're doing a project right now in DC where that's a historic property, right? So, and then lots of others. We're doing a hotel here, as I was telling Tim earlier, as we speak, we're doing a hotel here in Orlando for energy efficiency, because these rooms have to be cooled, nonstop. I mean, whether it's being used or not, you got to maintain a certain temperature. So this is a cool thing, right? So question for you guys is, what determines how quickly I get my money back? What determines, if my facility is a fit? So I use these extreme circumstances, right? You've got a curtain wall, but you see all those, even though it's a newer building, the glass to wall ratio is a big part. If you have a decent glass to wall ratio, your payback is great. That building has no payback, right? Because it doesn't have any windows. The windows are not accounting for the heat gain, so it really doesn't factor that in, right? So again, using those as extremes, glass to wall ratio, existing glazing type. If you've got a building that's 5 years old, you probably don't need film. Keep in mind that when we look at a building and do infrared imaging, we can also test, you know, and obviously Envacor does a lot more than just us, and that's why we work with ESCOs as well, is that we are a piece of the solution, and companies like Envacor and some of the other NAESCO members provide the entire solution, right? So as we look at that, when we do infrared imaging, we can also tell if they're leaky windows. We also have the ability to caulk those windows. Direction of the windows, north-facing glass, right? When you look at your facility, not a good payback. So east, west, south for sure. So, you know, when we look at opportunities, we say, okay, how do you identify opportunities? You can identify, let's say if you have a portfolio of buildings, you can identify the highest energy consumption buildings, the least efficient properties, the properties with the largest glass to wall ratio, right? Many different ways to skin that cat. Areas with the highest energy costs. I mean, we did a project in Hawaii, 1.3-year payback. Not normal. Do not think about that in the US. Cost is higher, different climatic conditions, right? So normally we see in an office building or something in a hotel, we see about 3 to 7 years is the range, depending on several other factors. So once identified, we can research and prioritize our recommendations. So let's just say you had a property and you said, hey, can you guys have a quick look at it and see if it's worth doing? Look, we're in a relationship-based business. We're not worried about the ability to say to you that, no, this building is not a good fit. Warranties have come a long way, right? And we're a little silly with this, but and again, you know, warranties do mean a lot. We're a publicly traded company, and there are other, you know, good technologies out there as well. 10 to 15 years for interior films. Life expectancy is about 20 to 25 years is what you should expect out of it. Just so you know, in the terms of warranties, we cover product and labor, not just product, right? So keep that in the back of your mind, is that 15 years later or 12 years later, something goes wrong in a building. If it starts peeling or bubbling or discoloring, we cover the product and the labor, not just either or. Okay, you know, Brian mentioned alternatives. People think blinds. I want you to think about the blinds. They're on the inside. Any sort of window covering, that heat's already penetrated the glass. You're not feeling it, but that room's going to get to a similar temperature with or without the window coverings, right? The other thing about window coverings is half the time they're up and half the time they're down, so you don't really have any control. Window inserts, good option, but window inserts focus on winter time, more of the insulation rather than the solar heat gain, right? The other thing is there's still a lot, you have to have certain types of frames in order to use them. There are some limitations of inserts, but they can be in cool climates, they can be a good option as well. PV, you know, good luck with the payback on PV. Photovoltaic, it's still got a long way to go. Replacement windows, again, if you have the budget for it, more power to you. These are just some numbers I shared with you. We can reduce the solar heat gain from 0.7 down to 0.1. I want you to think about the solar heat gain coefficient, which means that existing window was cutting out 35% of the heat. We can cut out 90% of the heat coming through that one. Insulation-wise, if it's got a U value of 1, we can bring it down to 0.6. 3 minutes, got it. I think this is the last slide. This is the last slide. So what happens next, right? So if you say, all right, look, is my facility a fit for it? We can eyeball it. We can Google Earth it from our offices in San Antonio. We're a global company. We've got offices in just about every continent. But let's just say it was in the US. We can Google Earth it and we can say, yeah, there seems to be some opportunities here based on what we're seeing here. We can have a call with the engineer to discuss high-level payback, calculate window area and orientation. This number 4 is very important. Benchmark the glazing. This is going to be very, very important, right? Is that we have to look at your glazing and see, okay, where are you starting off from? Confirm if the budget and high-level ROI makes sense, and so forth. So anyway, this is just to give you an overview of film. Any questions that come to mind?